Before viewing this video on fractional distillation, you must first view the demo video on simple distillation. That video contains information about setting up and performing distillations in general, and which pertain to fractional distillation but won't be repeated in this video. Distillation is a standard laboratory method for the separation of liquids based on differences in their boiling points. There are three common types of distillation: simple distillation, fractional distillation, and vacuum distillation. Simple distillation is used to separate components in a liquid mixture that differ in boiling point by about 70 degrees Celsius or more, while fractional distillation is used to separate mixtures with boiling point differences less than that. Vacuum distillation is reserved for compounds with very high boiling points, greater than 200 degrees Celsius at atmospheric pressure, which could possibly undergo thermal decomposition during a distillation attempted at atmospheric pressure. This demo video describes fractional distillation and focuses on how to assemble a fractional distillation apparatus, how to perform a fractional distillation, and how to properly disassemble a fractional distillation apparatus. A fractional distillation apparatus consists primarily of 6 pieces of laboratory glassware that are connected via ground glass joints to create leak-tight seals. The distillation head, water-cooled condenser, and bent adapter are secured by plastic clips called Keck clips to keep them from becoming unattached. The temperature of the distilling liquid is measured with a laboratory thermometer. In our labs, you'll use a digital thermometer. One of the key components of the apparatus is the distillation pot or distillation flask. It's a round bottom flask of varying size. A general rule of thumb is to use a flask whose volume is approximately double the volume of the liquid to be distilled. The most important part of the fractional distillation apparatus is the fractionating column, a long glass tube placed between the distillation flask and the still head, secured to the still head with a Keck clip, and packed with steel sponge, copper wire, or glass beads. The packing provides a surface on which numerous vaporization condensation cycles can occur with components in a liquid mixture. With each vaporization condensation cycle that occurs within the column, the composition of vapor is progressively enriched in the lower boiling component. The demo begins with the assembly of the apparatus, which can be broken down into 3 parts, starting with assembling the 3-piece unit of distillation head, water-cooled condenser, and bent adapter. First, lightly grease the portions of the ground glass joints furthest away from the opening. This is done to seal the connections, to provide frictionless rotation about the joints so you can turn them freely if needed during the distillation, and to prevent the connected joints from freezing together, that is, becoming permanently attached. Apply 3 or 4 small dollops of grease at points well separated from each other near the top of the male portion of the joints that are going to be connected to other joints. Don't squeeze the tube of grease like a tube of toothpaste. Use an applicator stick to have better control of the amount being transferred to the glass. If you use too much grease, it can work its way to the inner surface of the glassware and contaminate your liquid sample. Slightly twist the connected joint to make a seal and to check that it can turn easily and smoothly without much force. If it doesn't turn easily, add more grease and repeat. Secure the connected joints using plastic Keck clips, as shown here. Now connect the other end of the condenser to the bent adapter. As before, grease the joint before making the connection. Remember to secure the connected joints with another Keck clip. You'll need one more Keck clip later in the assembly. Set this 3-piece assembly aside in a safe place and proceed to assemble the rest of the apparatus. The second part of the assembly involves connecting the 3 portions of the thermometer adapter, and once that's done, you can insert the digital thermometer. The glass portion of the thermometer adapter has standard tubulation at one end and a ground glass joint at the other. First, attach the rubber thermometer fitting to the standard end of the glass portion, that is, the end that's not ground glass. Note that the hole in the fitting is too large to keep the thin stem of the digital thermometer fixed in place. A smaller diameter hole is needed for a more snug fit. For that, we use a perforated rubber septum. Then attach the septum over the rubber fitting. Finally, you can carefully insert the thermometer into the septum through the pre-made hole. Don't worry about adjusting the position of the thermometer in the adapter. You'll do that later. Once you've applied grease to the ground glass joint, set the thermometer adapter assembly aside and proceed with the rest of the setup. Once you've assembled the distillation head, condenser, and bent adapter as a single unit, and you've prepared the three-piece thermometer adapter assembly, you can connect those two units to a fractionating column and the distillation pot in a specific order and manner to complete the setup of the fractional distillation apparatus as demonstrated here. You begin by firmly securing the distillation pot to a ring stand or a metal rod in your fume hood. Use a two-pronged clamp that can firmly grasp the neck of the round-bottom flask. In this case, the distillation pot is a 50 ml round-bottom flask. The heat source is a small-sized heating mantle which receives a regulated supply of electricity from a voltage regulator that is plugged directly into an electrical outlet. Please note that you must never plug a heating mantle directly into an electrical outlet. The mantle would become incredibly hot, burn out, and potentially cause a fire. Make sure the regulator is turned off at this point. Use a small iron ring attached to the ring stand to raise the heating mantle just high enough above the bench top to allow you to move it rapidly away from the distillation pot when you need to stop the distillation immediately, such as at the end of the distillation. Take the time to make sure the distillation flask is in direct contact with the heating mantle and pushed firmly against it. Also make sure that the flask is held securely by the clamp and that the clamp is firmly attached to the ring stand. After all, you're using this assembly as the foundation upon which to build the rest of the apparatus, and you don't want the entire apparatus to fall to the bench top when you eventually lower the heating mantle. Now is when you add into the distillation flask the liquid that's to be distilled. In this demo, the liquid is a mixture of propanone, also called acetone, and 1-propanol, with reported boiling points of approximately 56 and 97 degrees C, respectively, at atmospheric pressure. Remember to always add 1 or 2 boiling stones to any liquid that you heat. Sometimes a boiling stick is used instead of boiling stones. Instructions in the experimental procedure will indicate which to use. Obtain a fractionating column. This one is packed with small glass beads. Grease the joint of the fractionating column. And then insert it into the joint of the distillation pot. Now insert the greased joint of the distillation head into the top of the fractionating column and secure it with a Keck clip. To prevent the condenser assembly from inadvertently twisting far away from the position you want, you need to secure it with a small, three-pronged clamp as shown here. Raise the clamp to an appropriate height before tightening the prongs of the clamp. Adjust the clamp at an angle such that the clamp prongs are at the same angle as the condenser. In this way, the condenser can eventually be grasped with all prongs touching the glass evenly. Clamp the condenser loosely to prevent creating any torque that might cause ground glass joints to disconnect. Connect the thermometer adapter assembly to the top of the distillation head and then adjust the position of the thermometer. Insert the stem far enough so that its tip is extended well below the sidearm exit of the distillation head but not into the fractionating column. Then turn on the thermometer, which should now be recording room temperature. You can now connect thin-walled hoses to the water-cooled condenser. Connect the water inlet hose to the lower nozzle and connect the water outlet hose to the upper nozzle. In this way, water enters at a low elevation and will fill the entire outer jacket of the condenser before exiting into the drain. Make sure you place the exit of the water outlet hose deep into a sink. The water at the tap passes through the nozzle and exits forcefully as a strong jet of water. Therefore, before connecting the inlet hose to the nozzle, open the tap to emit a modest flow of water, sort of like a weak water fountain. Only then should you connect the inlet hose. You can check the flow rate by examining the water flow from the exit hose. With the fractional distillation apparatus now fully assembled, the distillation can now proceed. For specific details about how to perform the fractional distillation of the liquid mixture in your assigned experiment, consult the instructions in the experimental procedure provided to you. Now is the time to turn on the voltage regulator to supply heat to the mantle, which in turn heats the liquid in the distillation flask. You normally start at a lower setting and then increase the voltage as needed while you're distilling. When the mantle is hot enough, you'll begin to see liquid boiling in the flask. But keep in mind that if no hot vapors from the distilling liquid have yet climbed through the fractionating column into the distillation head and condensed on the thermometer will still be at or near room temperature. Eventually, you'll begin to see the distilling vapors of the mixture component with the lower boiling point, in this case acetone, rise into the fractionating column and then condense on the packing material and on the inner walls of the column. The distillation should be carried out slowly to permit the numerous vaporization-condensation cycles in the fractionating column that are necessary in order to obtain good separation between the components in the mixture. To ensure this, at intervals, you'll periodically increase the regulator voltage in small increments to completely distill away the lower boiling components, and then eventually provide enough heat to allow the higher boiling components to distill. For the sake of brevity, only the distillation of the lower boiling component in this two-component mixture will be demonstrated in this video. That component is acetone with a boiling point of 56 degrees Celsius. The distillation of the higher boiling component, 1-propanol, is not shown. The vapors of acetone continue to rise and condense within the column. Note that the thermometer will still be at or near room temperature until it comes into contact with the distilling vapors. At this point, the distilling vapors of acetone are just beginning to emerge from the fractionating column and entering the distillation head. The acetone vapors are just beginning to condense on the thermometer, but they've not yet filled the distillation head, so the temperature of the thermometer has yet to read the boiling point of acetone. At this point, the still head is beginning to fill with the condensing vapors of acetone. And the thermometer is beginning to read its boiling point. Once the vapors of acetone rise to fill the distillation head and then condense on the inner glass surface and on the thermometer, you'll notice distillate collecting in the sidearm exit of the distillation head, and the thermometer will record the boiling point of the distilling liquid. The temperature will remain fairly steady until no more of that substance is left to be distilled. If heated properly, drops of distillate should emerge from the bent adapter at a rate of 1 to 2 drops per second. Be observant. Periodically check all glass connections and clamps of the apparatus to confirm they remain secure. For details about how to perform the fractional distillation of the specific liquid mixture in your assigned experiment, consult the instructions in the experimental procedure provided to you. The distillation continues until very little liquid remains in the distillation pot. Remember never to distill to absolute dryness in the distillation flask. With no more liquid left to evaporate and to take heat away from the glass surface, the flask will get extremely hot and it could crack. You can stop the distillation when the tops of the boiling stones start to appear above the liquid surface. At that point, immediately stop the distillation by loosening the iron ring and moving the heating mantle completely away from the flask. Be careful not to burn your hand on the mantle, as it will be very hot. Merely turning off the voltage regulator will not stop the distillation, as the flask is still being heated by a very hot mantle. You must first remove the heating mantle to stop the distillation and then turn off the regulator. When you've completed the distillation, wait for the glassware of the apparatus to become cool to the touch, and then begin to disassemble the apparatus. Store away your collected distillate and secure it so that it doesn't get knocked over accidentally. Start the disassembly by removing the thermometer adapter and then turn off the thermometer. Then remove the 3 glassware pieces connected by Keck clips and momentarily rest the still connected pieces on the bench top. Remove the fractionating column and safely set it aside. Unclamp the distillation flask and also set that aside. Disconnect the water inlet hose from the water nozzle before turning off the water. Drain the water from the condenser and remove the attached hoses. Finally, disconnect the 3 glassware pieces after removing the ket clips and return the ket clips to the storage container on the lab shelf.